And today we are working on another problem from LeetCode, and today it is about minimum distance between BST binary search tree nodes. The question says, given the root of a binary search tree, return the minimum difference between the values of any two different nodes in the tree. And what does that mean? That means uh, you have to you have to traverse this each of these each nodes in this tree and find their differences, and at the end return the minimum difference. For example, what does that mean? That means first you need to find out the difference between this and this, for example 1 and 2, which is 1, and then you find the difference between these two, for example 2 and 3, again it is 1. Then you check, for example, the difference between, for example 3 and 4, again it is 1. And then you check the difference between 4 and 6, here it is 2. But we are looking to find the minimum difference between these values. If we differentiate every two nodes in order, finally we need to return the minimum value. For example, at this point the difference is 2, but we are not looking for that. We should keep the minimum distance. Actually, that I don't know why they have used the word distance, because we are not looking for distance here, but we are looking for difference between the values, and we are trying to find out the minimum value, the minimum difference. So it is a tree data structure, and in tree there are two very common algorithms to traverse it. One was BFS, breadth first search, that we were traversing the tree level by level, and the other one was DFS, deep first search, that we were traversing a tree as deep as it has any leaf subtrees. So right now in this tree we see that what is the question and which approach should we take. So of course breadth first search is not a good approach here, because we are not trying to just traverse every node in this tree, but we have to start, for example, traversing from one side, from the most left or right, and continue processing until the last, or until the very first node. So for that reason we will choose DFS, deep first search. And in deep first search we had we could use recursion, and when using recursion we had three approaches to implement deep first search. One was the pre-order, post-order, and in-order. What does that mean? So pre-order means first you process the root, then you process its left, and then you process its right. That was the pre-order. That means you process the root first. And we have in-order. In-order means that first you process the left, then you process the root, and then you process the right, in order. That is, like, the word gives the meaning of this word conveys how we approach to solve the problem. We start from one side, and in order we keep processing, for example left, the root, and right. And the other approach was post order, and that means first we process the left, right, and then the root. It was called post order. So now in order approach is the most appropriate approach to solve this problem. For example, we have to start from this node, and for example first we need to compare this with this, and then we compare this one with this one, and then we compare this one with this one, and then we compare this with this. It is the most appropriate approach that we can take. You can use other approach as well, it's up to you, but that is the most appropriate one or easiest one. So however, when we start, for example, processing from here, that means we need to compare this with this. When we come to this node, we need to know its previous value, which was 1. And when we come here, we should know its previous value, which is 2. So we need to have a variable just to keep track of that previous value. And let minimum difference equals right now we don't know make it 0 or infinity, like it's up to you. Right now it is unclear, so let's say infinity. And so now let's create a function to implement DFS in the n order approach. So let n order DFS equals so we have to every time we are passing the node, the root, or let's say a node, because every time we are not passing a node, just a root, just to pass a node. So and of course every time check if the node has a value. If it is not null, it has to keep processing, otherwise it has to return. If the node doesn't exist, just return. Otherwise, keep processing from the left side, then the current or the root node, and then the right. So first call this function recursively on its left subtree in order DFS, and pass the node dot left to, so that it should start from the left side, and then if previous is not null, so find the minimum difference equals math.mean minimum difference and node dot value node dot val minus previous. And now keep the value of previous equals node dot value, and after that call this on the right side in order DFS, this time node dot right. Okay, and then just call this function, that's it, in order DFS, pass the root and return the minimum difference. Okay, now let's run and see what happens. Okay, so what is the problem? Oh, if it says we wrote it, not if. Okay, it passed successfully. I hope it was understandable, and I hope you understood this. In case you have any question, add them in the comment and I will go through your questions, and then we can find an answer to the questions. However, one note from my side, if you want to understand this easily, first you should know how the n order, post order and pre-order approaches work. if you know them, that means you can implement one of those approaches and solve this problem. Until the next lesson, have a nice time.